Have you ever built an application that just feels like a house of cards? You know, the kind where you're scared to even touch it? Especially when you're trying to stretch it across different clouds, like AWS and Azure. Well, today we're going to talk about how to get away from that fragile mess and build something that's truly fluid and resilient. So let's kick things off with the one question that probably keeps a lot of us up at night. We all jumped on the microservices bandwagon, right? We were promised agility, scalability, all the good stuff. So why is it that so many of our distributed systems feel, well, like they're ready to fall over at any moment? To figure that out, we have to look at the real culprit, what our source material calls talking services. We're about to pull the mask off a pretty sneaky villain in modern architecture, something you might be wrestling with right now without even knowing it: the distributed monolith. And this slide just nails that disconnect, doesn't it? On the left, you've got the dream of microservices, these perfectly independent, scalable, isolated little units. But the reality for so many teams, over on the right, is this tangled web of cascading failures. You know, where one slow service brings everything else grinding to a halt, data gets out of sync, and all your business logic is hopelessly snarled together. Okay, so the first core problem has a fancy name: temporal coupling. But honestly, just think of it like an old-school phone call. For the conversation to happen, both you and the other person have to be on the line at the exact same time. In the world of services, this means Service A is totally at the mercy of Service B being up and running right now. If B is slow or if it goes down, well, A immediately starts to suffer too. And then there's this even nastier problem: the dual write. This is what happens when a service tries to do two things at once. Imagine it needs to write an update to its own database and then send a message to tell another service about that update. What happens if the database write works, but sending the message fails? You've just created what's called dark data. A critical change happened, but the rest of your system is completely blind to it. And that, my friends, is how you get those maddening, impossible to debug data bugs. So when you add these problems together, you're forced to face a pretty tough realization. You don't actually have microservices. What you have is what this source material perfectly calls a distributed monolith. Yeah, your services might be deployed in different places, but they are so logically tangled and dependent on each other that you've lost all the benefits you were hoping for. Okay, so enough with the doom and gloom. How do we actually break free from this trap? Well, this brings us to a much better way of thinking: the event-driven nervous system. The whole idea here is to completely change our approach. We're moving away from making those fragile direct phone calls, and instead, we're all contributing to a kind of shared, permanent memory for the entire system. And this quote right here, it gets to the absolute heart of the solution. The idea is to use something called an immutable log, think Apache Kafka, as the central nervous system. Every single important thing that happens in the business gets published as an event to this log. It becomes the one and only source of truth. And the best part is, it's permanent and you can always go back and replay it. Now, this is where things get really cool. A service mesh, the old way, is all about managing those fragile, synchronous phone calls between services. But an event mesh, that's a whole different ballgame. It manages asynchronous events. It's not a phone call. It's more like a persistent radio broadcast. A service can just shout an event out into the world, and any other services that care can listen in and react whenever they're ready. The original service doesn't even have to know they exist. Now that is true decoupling. And here is what it actually looks like. Check this out. We've got two totally separate Kafka clusters. One's living in AWS, the other's in Azure. But they are seamlessly connected with a piece of tech called a cluster link. Now, this isn't just copying some data back and forth. No way. This is creating a single, logical data fabric that literally stretches across both clouds. This is how you make native multi-cloud a real thing. All right, so we've got our superhighway for events all set up. But what about the services themselves? How should they be designed? This brings us to a super important principle for this whole architecture. We want smart endpoints and dumb pipes. All the business logic lives at the edges, not in the plumbing. So what does a smart endpoint actually look like in practice? Well, this diagram is a perfect example. It's an enterprise-grade setup for an Azure OpenAI service. You can see it's not just some simple function call. It is a complete, intelligent, and self-contained system that has all the logic it needs to do its job without getting all tangled up with everyone else. Let's actually follow a request through this smart endpoint. First, it hits API management, which takes care of the front door stuff like security and rate limiting. Then it goes through another security layer to handle identity and secrets. Only then does it get to the core logic, where it might talk to OpenAI, hit a cache for speed, whatever it needs to do. And the whole thing, top to bottom, is wrapped in solid monitoring. See, all the intelligence for this one business job lives right here at the edge. And this is why this smart endpoint approach is such a game changer for big companies. It's built for the real world, it's designed to scale automatically. Security isn't an afterthought, it's baked in from the very beginning. And it's super flexible. By packaging up all its own logic, the service becomes this reliable, self-sufficient building block in our system, not just another fragile dependency. So we've got our event backbone, we've got our smart services. Now for the final boss battle, making the actual data flow seamlessly between clouds. To pull this off, we have to defy a really powerful force in computing called data gravity. So what on earth is data gravity? It's actually a pretty simple but powerful idea. The more data you collect in one place, the heavier it gets, metaphorically speaking. It becomes harder and more expensive to move. And just like real gravity, it starts pulling applications and services into its orbit. This is exactly why you end up with these massive data silos, with all your AWS data stuck in AWS and all your Azure data stuck in Azure. And this slide shows us exactly how we break the laws of data gravity. Let's just follow the data for a second. Over on the far left, a change happens in a database in AWS. Now, there's a special tool watching that database, kind of like a security camera. It's called Debezium. It instantly sees that change and publishes it as an event to our AWS Kafka cluster. From there, that cluster link we talked about mirrors the event over to the Azure Kafka cluster, basically in real time. And finally, a payment service running over in Azure can just pick up that event and act on it. The data just effortlessly flowed from one cloud to the other. And here is the big aha moment. This entire pattern, which is called change data capture, or CDC, is the ultimate solution to that nasty dual write problem we started with. Now, our services don't have to juggle two things at once. They do just one thing, write to their database. The event becomes a guaranteed automatic consequence of that database change. This is what makes real, reliable, event-driven systems possible. Wow, we've covered a ton of ground, right? We looked at the problems, the communication backbone, the smart services, and the data flow. So now, let's put it all together into a practical blueprint you can actually use for building these kinds of resilient, multi-cloud systems. Think of this as your new architecture checklist. First, decouple your services using an event mesh. Stop making those direct, fragile calls. Second, build smart endpoints that own their own business logic. Third, use change data capture or CDC to reliably stream changes out of your databases. Fourth, you gotta use a schema registry. Think of it as a rulebook for your events to make sure nobody sends broken data. Fifth, bridge your clouds with tools like cluster linking. And last but not least, you have to guarantee data integrity with something called exactly once semantics, which just makes sure you never lose or accidentally duplicate an event. So I'm gonna leave you with this one final thought to take back to your team. I want you to look at your own architecture and honestly ask this question. Are our services just having a bunch of fragile synchronous conversations that are bound to break? Or are they all contributing to and building a resilient shared memory that allows them to be truly independent? Because how you answer that question, well, that's going to define the future of your systems.